Before we use y equals to represent a function, so for a linear function, we could use y equals mx plus b. If I give you a random linear equation, we could write it as y equals to x minus 1. And also we could write a quadratic equation. So just pick a random quadratic equation, y equals 2x squared minus 3x plus 1. So they are the linear equation, quadratic equation. And in future, we want to use a function notation. So the first one, we could give it a name, f at x, and the second one, we gave it a name, g at x. So it will be easier for us to say function f, function g, instead of always say, okay, this linear equation, this is a quadratic equation. So it's just convenient when we have more than one equation there. So in the function notations, the y and the function notation, f at x or g at x, t at x, v at x, they are interchangeable. So if you don't want to see the function notation, you could replace f at x with y. And we read f bracket x bracket f at x, or read it as f of x. And it's not f times x. So for function notation, f at x together, there's not multiplication. So it's not f times x. F at x together is a function machine. As the name of the function is f, the input is x. So f at x give you two informations, the y and also x. So input, output at the same time give you the information. So input is x and output is f at x. F at x together is y value. So for example, we are going to see example 1, evaluate a function. If f at x equals 3x squared minus 4x plus 1, find f at 6. So if we translate to what we know before, we could write this equation in another form. So y equals interchangeable f at x and y. So we replace f at x with y. So y equals 3x squared minus 4x plus 1. And for question A, f at 6, it means input x value is 6. And you are looking for y value when x equals 6. Y equals what? So that is equivalent with f at 6. So f at 6 give you the input, x value is 6, and the value of f at 6 is the y value. So how are we going to do it? We are going to do the substitution. When you are looking for y value, if it's a function, the y is isolated, we always do the substitution. Just substitute the x value to replace the x with 6. So we are going to have y equals, or we write it in function notation, we are going to write it as f at 6. F at 6. Then we replace the x value with 6. 3 times bracket 6 squared minus 4 times 6, then plus 1. So we do the bad math. We do the exponent 6 squared first before we do this multiplication. 3 bracket 6 squared means we have the multiplication here. We do the exponent first, then do the multiplication. So we have 3 times 6 squared give you 36. Then subtraction, adding, subtracting, multiplying, we do the multiplying first. 4 bracket 6 means 4 times 6. So 4 times 6 give you 24. Then plus 1. We have multiplication. 3 bracket 36 means 3 times 36 minus 24 plus 1. By the math, multiplication first. So 3 times 36 is 108. Then minus 24 plus 1. For adding, subtracting, we do it from left to right. Then we have 84 plus 1 is 85. Then it's done. So this is how you evaluate a function. So f at 6 means when the input x is 6, what's the output of function f at x. So you are looking for the substitute 6 here, then look for the value of this expression. So we are going to practice on question B. So f at this time we just do the substitution. X equals -1/2 to the right side of the function notation. So we have 3 times -1/2 bracket squared, then minus 4 times the x value, we replace it with this input, -1/2, then plus 1. So this is a fraction. Squared means -1/2 times 1 or -1/2. Numerator times numerator, denominator times denominator, we have 1/4. Then minus 4 times -1/2. Numerator times numerator, denominator times denominator, you are going to have -4 times -1 is +4. Then 1 times 2 is 2. Then plus 1. So numerator times numerator, 3, we could think is 3/1. So 3 times 1 numerator is 3. 1 times 4, denominator times denominator is 4. Then plus 4 divided by 2 give you 2. Then plus 1. So we want to change everything to the same denominator. The common denominator, least common denominator is 4, so we times 4 to both numerator and denominator to change it to same denominator. Then we add or subtract the numerators together. So 3 plus 2 times 4 give you 8. 1 times 4 is 4. So the final answer will give you 15/4. So this is a fraction, multiplication, and question C. F at 0, we sub in 0. X equals 0 to the function notation, original expression. We have 3 times 0 squared minus 4 times 0 plus 1. So 0 squared is 0, 3 times 0 give you 0, 4 times 0 is 0 plus 1, so the answer is 1. So this is how you do the evaluation of a function f at x. it's not f times x, so it's not the whole thing times x. This one means input x equals 6. This number means input x is negative 1 or 2. F at 0 means x equals 0. You sum in, then the value of this expression is f at 0. So this is for example 1. Then we are going to continue to practice on evaluation. So sometimes it's not a number. So this one, f at a means you sub in x equals a to the given function notation. So all the x value, we change it to a. So 4 times a squared minus 2 times x is a, then plus 1. The a value is not given a numerical value. This is a final answer. We couldn't go further, no like terms. And the same thing, so this time the input is x over 2, so we change the x to x over 2 squared minus 2, the x change it to input x over 2, then plus 1. Then we do the simplification, so x over 2 is x times over 2 times x over 2, we have x squared, then 2 squared is 4. Minus this one, 2 times x over 2, we change 2 to fraction, is 2 over 1. So numerator times numerator, denominator times denominator, 2x over 2, we could cancel 2 out, you have x left, then plus 1. So this one, numerator times numerator, denominator times denominator, 4 and 4 we could cancel out. We are going to have x squared minus x plus 1. So a plus b, we sub in a plus b, we have 4 bracket a plus b bracket squared minus 2 times a plus b, then plus 1. We could simplify it by times it out. So a plus b times a plus b, you are going to have a squared plus ab plus ab plus b squared. Then minus 2 times a, 2 times b. Minus 2a minus 2b, then plus 1. Simplify ab plus ab, we call it like terms. We add the number at front, you have 2ab. Then 4 times each term, we are going to have 4a squared. Plus a times 2 is 8. ab, 4 times b squared is 4b squared. Then minus 2a minus 2b plus 1. We check, do we have any like terms left? Same variable, you need to have same degree. This degree 2, this degree 1, not like terms. So this is simplified, simple list form. So that question C is done. For question D, you have 2 terms, f at x squared minus f at 2x. So this one we sub in x squared to x. So we have f at x squared equals 4x changed to x squared, then squared, minus 2 times x changed to x squared, then plus 1. And for the f at 2x, we sub in 2x for x minus 2 times 2x then plus 1. Then we combine them together. We are going to have 4x to the exponent 4 minus 2x squared plus 1. Take away the bottom one. We expand it. You are going to have 2 squared is 4. 4 times 4 is 16x squared. Then 2 times 2, 4x plus 1. Get rid of the bracket will be minus 16x squared plus 4x. Then collect the like terms. You will have 4x to the exponent 4 negative 2x squared minus 16x squared. They are like terms. We have minus 18x squared. Minus 4x is plus 4x. For the constant, plus 1 minus 1 is 0. So this is the final answer for question D. And after that, we are going to see question example 3. Now you may have two functions. F at x equals x squared minus 2x, g at x equals 1 minus 3x. It asks you to show that f at 3 is greater than g at 3. So we are going to evaluate f at 3 equals what? F at 3 means x equals 3 sub in to function f at x. So equals x equals 3, so 3 squared minus 2 times 3. Then you have 9 minus 6. So multiplication, do it first before subtraction, is 3. And for g at 3, it means x equals 3 for function g at x. We sub in is 1 minus x equals 3, so 3 times 3. You will have 1 minus 9 is negative 8. Because 3 is greater than negative 8, so we know that f at 3, this is 3, is greater than g at 3. The reason for it is 3 is greater than negative 8. And 3 is equal to f at 3. Negative 8 equals to g at 3. So therefore, f at 3 is greater than g at 3. Explain what this means about their graphs. So it means on the graph, the x value is 3, and one of the point is f at 3 is here, is 3, and another g at 3 is negative 8. It is here, g at 3 is negative 8. So on the graph, it means that f at 3 is a 3 comma f at 3 is a point on the graph, and 3 comma g at 3 is another point on the graph. So the function f at x is about the function g at x at x equals 3. So 3 comma f at 3, it is like the xy coordinate, the point on the function f at x. And question B, determine g bracket a minus g at a subtract 2b. So question B, it means the x value equals a minus 2b. We sub in this one to the function zx. So remember, you need to sub in to the correct function. So this g, we sub in the g a minus 2b to x. So it's 1 minus 3 bracket a minus 2b. Then we expand it and simplify. So 1 minus 3 times a is 3a, minus 3 times minus 2b, negative 3, negative 2 is positive 6b. So this is just the practice. A, b could be any numbers. This is just practice on algebraic skills. So this is for B, and for question C, f at a plus 3, it means x value equals a plus 3. So sub that one into this f at x. So we have f a plus 3 equals a plus 3 bracket squared minus 2 times a plus 3. Then we do the expanding. So a plus 3 times a plus 3. Squared means times it. Same thing out. Then a times a squared. A times 3 is 3a. Then second term times each term in the second bracket. So 3 times a, 3 times 3. That is for the first a plus 3 bracket squared. Then minus 2 times a plus 3 is monomial times binomial. So negative 2 times each term in the bracket. Minus 2a minus 6. Then collect the like terms. A squared, 3a plus 3a is 6a, plus 9, take away 2a, take away 6. Then collect the like terms. A squared, 6a minus 2a, same variable, same degree, they are like terms. We have plus 4a. Then 9 minus 6 is plus 3. So this is for a plus 3. Then we figure out g at a minus 2. Then we subtract these two expressions. So a minus 2 we sub in here, 1 minus 3 bracket a minus 2. Then expand. We have 1 minus 3a, then plus 6. Then subtract these two terms, what we got together. So a squared plus 4a plus 3, that is f at a plus 3, then take away g at a minus 2, 1 minus 3a plus 6. Then get rid of the bracket. You have negative sign, you are going to switch the sign in the bracket. So a squared plus 4a plus 3 minus 1 plus 3a minus 6, then collect the like terms. A squared, 4a, 3a, give you 7a, plus 1 minus plus 3 minus 1 minus 6, 2 minus 6 minus 4. So this is answer for question C. So question C, we find out f at a plus 3 equals and g at a minus 2 equals, then subtract those two expressions, then simplify. You will have a squared plus 7a minus 4. Then question D. Question D is f dot g at 2. This notation also equivalent with f at g at 2. So you are going to use the g at 2 as input for function f. So for this type of question, you are going to from inside go outside. So do the find the g at 2 first. After you find the value of g at 2, then use this one as x value sub into function f. So you are going to do it g at 2 first. G at 2 means x equals 2 for function g. So 1 minus x equals 2. 3 times 2 give you negative 5. Then f at g at 2, the g at 2 now is a number. And remember, it's not g times 2. So it's the g at 2 is x equals 2 sub into the function notation. The function. So f at negative 5, we sub into x equals negative 5 to the expression for f at x. So we have negative 5 bracket squared minus 2 times negative 5. Then we have negative 5 squared is 25. Minus 2 times negative 5, negative becomes positive, is 25 plus 10 is 35. So this is a more than one function given that you need to be careful subbing to the corresponding function. So whatever inside the bracket means that is your x input. It's not g times a minus 2. It's not 1 minus 3x times a minus 2. This one represents the input x value is a minus 2. You do the substitution, then the expression you have is a g at a minus 2. So that is example 3. Then we continue to practice on evaluating function by using function notation. So example 4, if f at x equals 2x plus 3 and g at x equals negative 3x plus 4, determine the following function combinations. Okay, so find the value of x if f at x equals 15. So this one, f at x is your output. So it asks you to find what x value sub in will give you the output for this expression equals 15. So we are going to set up an equation. So f at x is equivalent with 2x plus 3. So it's 2x plus 3 equals 15. You also could think it's just y equals 2x plus 3. This one is y equals 15 and ask you for x value. So 2x is linear equation. We want to isolate x. Then we are going to do the backward of BADMAS, adding, subtracting first. Move to other side. plus 3 becomes minus 3, so we have 12. Then in order to solve for x, we move the 2 to other side. We isolate x. 2x means 2 times x. Opposite operation will be division, so we divide it 2 to both sides. 2x divided by 2 give you x. 12 divided by 2 give you 6. Then x equals 6, it means f at 6 will give you 15, so you could check. So now we want to check if it's true. So we sub in 6. This is, for this question, x equals 6 is your solution. You don't have to go further, but always you could check if it's true. So f at 6 equals 15 or not. We sub in x equals 6 to this function notation, replace x with 6. So 2 times 6 plus 3. Then 2 times 6 is 12, 12 plus 3 is 15. Then we know it is right. So this is what you are looking for. And this one asks you to find the value of x if f at x equals g at x. So the left side f at x equals g at x. We sub in the right side to replace f at x. So 2x plus 3. Equals negative 3x plus 4. Then we want to isolate x, we move x to one side, collect the like terms, and the 3 number to other side by doing opposite operation. Minus 3x to move to the left side is plus 3x. Then we have 2x plus 3x. The right side is 4 minus 3. So we have 1 equals 5x. Then move the 5 to other side. Doing opposite operation is division, so x equals 1 over 5. And actually what we have done for this one, it means you have 2 lines. So 2x plus 3, how we graph it, this is mx plus b. So b is 3. We find the 3 here. Then slope is up 1, up 2, right 1. So we have an equation. It's a linear equation. So we have a line here, and another one is 4, and down 3, right 1. Then we graph it. The 2 lines will intersect at x value is 1 over 5. So f at x equals g at x. It means you are looking for the point of intersection, which x value. At that point, that the 2 lines will intersect at each other. Okay, so this is the x coordinate for the point of intersection. And for this one, also you could think is you are looking for, you draw a horizontal line, y value is 15, then you are looking for the x value, where the x value will give you the point 6, 15 on the straight line f at x, the first linear function. So you will see that 6, f at 6, it is a point on this straight line. So in general, it's x comma f at x will give you the point on this function. So f at x is equivalent with the y value. So x coordinate, y coordinate, and that represent a point for function f at x. So we are going to continue f at g at 3. So remember, this is equivalent with f at g at 3. So we go from inside to outside. So we find input x equals 3 was a g at 3 value, then use this value as x value, sub into function f of x. So g at 3 equals negative 3 bracket 3 plus 4. So replace this x value with the input x equals 3. So it's not g times 3, not negative 3x plus 4 then times 3. This is function notation, it's not multiplication. No operation multiplication here. G at 3 means input x equals 3, substitution. So you will have negative 9 plus 4 is negative 5. Then we sub in negative 5 to function f at x. So f at negative 5 equals 2 times negative 5, then plus 3. The reason for it, f at x is 2x plus 3. So whatever the in bracket is your x value. Replace the substitution. Negative 5 put here. So 2 times negative 5 plus 3. Then we have negative 10 plus 3 give you negative 7. And this one is f at g at 3. So g at 3 is replace g at 3 with negative 5. Then we sub x equals negative 5 into the f at x. So f plus g, then 1. So this one is combination of function f plus g. We could put these two functions together. Then it is a new function. We could do the f at 1, then plus g at 1. So this is, we could write it separately. So combination of function f and gi together, we could write it separately. So f at 1, we sub in the x equals 1 to the function f of x is 2 times 1 plus 3. And plus g at 1 is negative 3 times 1 plus 4. So we replace the 1 x with 1. So 2 times 1 plus 3 give you f at 1. And the negative 3 times 1 plus 4 give you g at 1. Then we do the simplification. 2 times 1 plus 3 is 5. Negative 3 plus 4 is 1. So it is 6. This is for this part. Then 2 times f at -1 plus 3 times g at 2. So you are going to look for the value for 2 f at -1 first, then times 2. So 2 times, we could sub in -1 to function f. Function f is 2x plus 1, so put -1 to here. Is 2 times -1 plus 3. That is 2 times f at -1. And plus 3, g at 2 is x equals 2 to function g at x. So -3 times 2 plus 4. So I will continue next line. So plus 3, then times g at 2, -3 times 2 plus 4. Then we have 2 times -2 plus 3 is 1, plus 3 times -6 plus 2, 4 is -2. Then we are going to have 2 times 1 is 2, then do the multiplication first. 3 times -2 is -6, then you have -4. So this is the evaluation for function notation. Then the next one is see how you understand what f at 2 represent. So for function notation, f at 2, it means when the input is 2, what's the output, what is a dependent value. When the independent value is 2, so we check independent value -2, -1, 0, 1, 2. Okay, this one is x equals 2, and the y value represent is the function f at input 2. So from here you will see you are looking for the y coordinate when the x coordinate is 2. So f at 2 equals 13. You just read the point when the input is 2. So you are looking for output when the input is 2. So this is what function notation means. F at 2 means output for input is 2. So this one graph is given. It asks you when x equals 2, what's the output, what's a dependent value, what's a y value. So when x equals 2, y, the dependent value equals what? So see the point, input is 2, x value is 2, y value is 1. Then it means f at 2 is 1. So that is all for this video, this lesson. So it's evaluate of function notation by doing the substitution. If you want to evaluate a function, then if you have the x value given, what you are going to do is just substitute. Just substitute that x value into the expression, then find the value, evaluate this expression, then that is your function's value when the input inside the bracket x is 6. So you need to understand, evaluate a function means substitute, do the substitution. Whatever in the bracket is the input, x value, the independent value. Sometimes you may not have the x here, you could have other variables. You just replace that variable with whatever the value inside the bracket. F at 6 is not f times 6, it's just f at 6 together is input is 6, find the output. If it's not a number, it's an expression, you just need to replace x with expression, then simplify. So if the output is given, to find the input, you set up the equation. So f at x, they are same, you replace f at x with a right side, then set up an equation. Isolate x if it's a linear equation by moving numbers to other side, doing opposite operation. Plus becomes minus, minus becomes plus, multiplication becomes division. You could check by substitute x equals 6 back to the expression to see the output is 15 or not. And also we have practice on if the set of data given, you find f at 2, then you just look for the input is 2, what's the output? The output is the value for the function notation. And from the graph, we find when the x coordinate is 2, then what's the y coordinate? That is the output. So if we are looking for f at 3, then you look for when x equals 3, this one is no, nothing, then we may try the, if I ask you to find f at 4, then it just find when x equals 4, what's the y value? And this equation represents two things, x value and y. So this is a point, 4, 2 is a point on the graph. So thanks for watching.